All right, welcome to Chapter 8, Section 6, called Changes in Dimensions. This is for Math 8. So a couple things that you'll see on your screen. The first thing you should see is a due date. I don't see it on my teacher preview here, but you will see it on your student screen. The second thing is the number of attempts. We always allow unlimited attempts on homework, tests, and quizzes, so you can come in and complete them as many times as you would like. Number of questions just tells you how many questions are on this particular assignment. Grading policy is best score, so whichever attempt is the best one is the one you get to keep. Partial credit is enabled, which means if you answer, one of two questions, then you get credit for the one question or however many you answered correctly. Please remember, once you start your homework, you must finish it before you can work on anything else. What that means is when I click Start down here, down in the bottom right corner, we will see a Submit Assignment button. We need to make sure that we click that Submit Assignment button when we want to leave the screen. So we don't come up here and close the tab. We don't just close our computer, because Alex is going to assume you want to leave this attempt open. Remember, you have unlimited attempts. There's no reason to leave it open. Two big things it does when you click Submit Assignment. Number one, doesn't lock you out of all your assignments. Just like that last screen said, you have to finish everything before you can work on anything else. That means it's going to lock you out of all of your assignments because it's assuming you're leaving this attempt open for some reason. As long as you have green check marks, you've tried this one and you click check and you've gotten it right, you're not going to have to redo it. So it saves your place. So that's a big one. Don't get locked out of your assignments. The other big one is it actually affects the grade book when you click Submit Assignment. So until you click that button, your account's basically paused. Us teachers don't get to see what you've been working on. So good habit. Always click that button. All right, on the side here, we have some extra tools. So calculator's not always open, but it is open right now. We also have explanation, example, and message center. So these three are always open. Explanation tells you you're going to lose your current question attempt because it's literally going to give you the solution to this question. So you're not going to get to see the solution to the question and then come get to type it in. Sorry, that's not how this works. Example will show you an example of exactly what it is we're looking at, or not exactly, but something very similar. So we can even say a designer builds a model of a minivan, a designer builds a model of a car. So very, very similar. And it's going to have you go through. So they give us a scale factor on this example, just like they give us a scale factor here. And they want us to find 3 ratios based on the information that they give us. So find the ratio of the surface area of the model to the surface area of the original, then the width of the model and the width of the original, the volume of the model and the volume of the original. So they want us to go through and look at the idea of how we use scale factor based on changing from length to area to volume. So we're going to look at that. And this is called the Law of Similitude. I hope I'm saying that right. That's how I've always pronounced it, but sometimes I realize I've been pronouncing things wrong for a very long time. So we're going to go through and we're going to take a look at this. Once you're happy with the example, you can close it. You can open another one if you'd like. It'll give you a brand new one. And you can also message your teacher directly from the screen so that they know where to come help you because it attaches a picture. All right. So let's take a look at the Law of Similitude. So what this says is if I have a scale factor, and this is the scale factor based on length. So this is just the basic scale factor. So this is the scale factor of a length. So just any basic length. If this was a side length, a height, if it was a perimeter, anything like that, anything where it's just a measurement, just a length, this will be our scale factor. So if we read these, we have the ratio of the height to the model and the height of the original. Well, height, that's a length. So the model is 3 and the original is 20. And what this means is if we're thinking, of bringing it down, this could be, 3 centimeters, and this could mean, 20 feet maybe. I don't think that would actually be accurate necessarily, but that'd be a very small change. But it could say every 3 centimeters in the model actually means 20 feet in real life. Something like that, or 20 inches in real life. Since it's a car, I was going with a little bit longer, although 20 feet is very long, so I'm not sure that we would do that. We could say every 3 inches on the model is 20 inches in real life, or something like that. It's just something to convert it. So I can make this model smaller, but I still have the side lengths. I can still convert it back and forth. So the next one says the ratio of the volume of the model to the volume of the original. Well, we can still take this same ratio, but volume, instead of it being one-dimensional, so this is one-dimensional, this is three-dimensional. So I need to cube it before I can use it as a scale factor for any kind of calculations. So I'd have to go 9 cubed. Remember, that's not 3 times 3. It's 3 times. It means 3 times 3 times 3. Sounds very similar when I say 3 times 3 or 3 times, but it's different. This is 3 times. I don't want 3 times 3. That's only 9. I want 27. Dang it, go away. 27 over, and this is 23 times. Not 20 times 3, 20 times itself 3 times. So we'd have 20 times 20 times 20. I'm going to be a little bit lazier here and go 20. And then I can hit this button here, and it'll give me a box for the exponent, and I can put it in like that. So I have 8,000, like that. So this is my scale factor for the volumes. So I can go 27, whoops, not 8, 27 to 8,000. All right, and then surface area. So find the ratio of the surface area of the model to the surface area of the original. So we're going to go back to that same surface area here. And remember, length is one-dimensional, volume is two-dimensional, or three-dimensional, and area is two-dimensional, length and width. So volume means that, I can fill it up with air, with water, with whatever. It's a container, kind of an idea. Area is just kind of a flat surface. How much, I don't want to say space necessarily. I guess that's a good way to say it. How much space does it take up? If I want to say, like, how much space does this rectangle take up on the whole page? Well, that's its area. But if I turn it into a box, like this, boop, 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 and I say, okay, well, how much can I put in the box? Now I'm talking about volume. So just be careful about which one you're talking about. So now we're going to square it. So 3 times 3, again, not 3 times 2. 3 times 3, which is 9. And this is 20 times 20, which I believe is 400. I'm going to check just to make sure. 20 squared is 400. So I get 9 over 400. Check. All right, so that's that guy. So this is just showing us the scale factor, how to do this. Now they're going to actually ask us to calculate with this idea. So using this same idea, now we need to actually do something with it. So the two similar prisms have widths as shown. So I have 7 centimeters and 8 centimeters. Note, the figures are not drawn to scale. Well, why are they telling me that? Specifically because they don't want me to go grab a ruler and try to take some measurements, okay? They just need to trust that it's 7 centimeters and 8 centimeters. All right, so it says if the volume of the prism on the left is 686 centimeters cubed, find the volume of the prism on the right. All right, well, they didn't tell me what the scale factor was, did they? Not straight out, but here are 2 lengths. I have the scale factor. So if I want the volume on the left to the volume on the right, so here's the left and here's the right. There's my scale factor, and this is the scale factor for any length. So what if they ask me about length again, I can very easily find the length based on this scale factor. The first thing they're asking me about is volume. So remember, volume is cubed. It's 3-dimensional. I have length, I have width, I have height. It's something I can fill up. It's a container. So I'm going to go over here and I'm going to say 7 cubed, and that's 343 over 8 cubed, which is 512. All right, so this is my scale factor for volume, but now I have to go a little farther than I did in the last problem. The last problem, they just wanted me to find the scale factor and stop. Well, now I need the scale factor to find the missing piece that they actually want me to find here. So it says, find the volume of the prism on the right. So I know this is the scale factor. It's going to equal, I can set it equal to these 2 pieces. This is the left and this is the right for my scale factor. So I have the volume of 686 on the left, and they want to know what is the right. So I'm just going to use R. You can use any variable you would like. Once I have a proportion set up, and we've done this a few times over the last couple weeks, we're going to do cross multiplication. Cross multiplication. So we have 343 times R, so 343R equals, so we have 512 times 686 equals 351,232. So 351,232. And I'm going to divide both sides by 343 because I want to get R by itself. It's being multiplied. I want to divide so that when I divide 343 by 343, it cancels. I have R equals, I just need to come back over here to my calculator and go divided by 343 equals 1,024. So the volume on the right is 1,024. Oop, typed that in wrong. 24. And does that make sense that it's bigger? Yes. This is a smaller rectangular prism. This is a larger rectangular prism. So it does make sense that it's larger. I had 686, now I have 1,024. So that does make sense that one is larger than the other. All right, so the second part here, it says, if the surface area of the prism on the left is 392, find the surface area of the prism on the right. So now we're going to go back to our handy dandy drawing board here. And we're going to look at area. So 3-dimensional for volume, 2-dimensional for area. Area represents kind of length times width. So we have 49 over 64. So remember, this is my ratio for area. Now I can set up a proportion. And again, it's left, right. So I have my left is 392 for the surface area, and I don't know my right. And it's okay if I use the same R. I can use a different one if that's kind of messing you up. If they're not going to equal the same thing. This was volume, this is going to be area. But you can use different variables there. You can use the same one. Or just using it as a placeholder so that I can go through and do my cross multiplication here. So I have 49 times R, so that's 49R equals, and we have 392 times 64, and that's 2,588, 25,000. I'm going to divide by 49 on both sides because it's 49 times R. So 49 divided by 49 cancels out, and I have R equals, go divided by 49 equals 512. So now I have 512 centimeters squared. And again, we had 392, we have 512. That makes sense. This guy's smaller, this guy's larger, so it would have more surface area. All right, the last one says if the height of the prism on the left is 14 centimeters, find the height of the prism on the right. So height, that's a length. So we're actually going back to our 7/8. I don't need to do anything at all to it. That is the ratio for the lengths. So if on the left, because it's still left, right, if the left is 14, what is the right? So I'll just go with X on this one, so I'm using a different variable. So we have 7 times X. And with this one, because it's a little easier to see exactly what's going on here, say, well, what do I need to do to 7 to get to 14? I have to multiply by 2. So I'd have to do the same thing to 8. So I know X is going to be 16, but I can go through and go like this and say that's 7X equals 8 times 14 gets me 8. Ooh, why did I not type in here? 8 times 14 gets me 112. And then if I divide by 7, 7 divided by 7 cancels. And I come over here and go divided by 7 equals 16. I don't know. Oh, I started to type it in up here. That's where that 8 went in the first place. Say, why did I have that typed there? But this one is a little easier because I can just say, well, how do I get from 7 to 14? I have to do the same thing at the bottom. You can do that up here as well. How do I get from 49 to 392? And I have to do the same thing from 64 to R. And that would tell me what R would need to be. So it's just, more than one way to look at that when you're looking at the proportion. If cross multiplication is something that you don't particularly like to do, you can look at that a little different and say, well, if I wanted to go from 343 to 686, I would have multiplied by 2. So I'm going to do the same thing on the bottom. I'm going to multiply by 2, and I would have arrived at 1,024. With this guy, I don't know that one right off the top of my head. Let's see. 92 divided by 49. So that's 8 of them, so I'd have to multiply by 8 to get there. So I would have had to kind of figure that one out, because that one doesn't come quite as easy to me. I wouldn't have seen that right away. But I have to multiply by 8 on the bottom here, and that would have also got me 512. So you can see like what's happening from one to the other, either across the top or across the bottom, and I have to do the same thing where my missing piece occurs. All right. So that was chapter 8, section 6. I believe that was the last section for chapter 8, so I will see you in chapter 9.